Hello, in this video I'm going to solve the following problem for you. An overdamped harmonic oscillator satisfies the equation x double dot plus 10 times x dot plus 16x equals to 0. At time t equals 0, the particle is projected from the point x equals to 1 towards the origin with the speed u. Find the subsequent motion. Show that the particle reached the origin at some later time t if u minus 2 all over u minus 8 equals to e to the power 6t. How large must u be so that the particle will pass through the origin? That would be a good idea if you pause the video at this point and give it a try. If you do the calculations correctly, the answer to the problem is x of t equals to 1 over 6 times u minus 2 times e to power minus 8t minus 1 over 6 u minus 8 times e to power minus 2t. And the particle passes through the origin if u is greater than 8. Okay, so this is the differential equation governing a motion. So we need to solve this. This is a second order linear homogeneous differential equation. You probably know from your differential equation courses that in order to solve this, I need to find the characteristic equation of this equation because it's just a simple quadratic equation. So for example, let R be my unknown. So this will be r squared plus this coefficient times r plus this coefficient. And I need to solve this quadratic equation. I use factorization, so I put one r here, one r there. I ask myself, are there two numbers whose sum is 10 and the product is 16? So simple, one of them is 2, the other one is 8. It becomes equal to 0. Of course, you can use ABC formula as well. Okay, so the product of two numbers is equal to 0. Either the first one is 0, so this means that r is minus 2, or the other one is 0, it means r is minus 8. Then, of course, I can simply write the general solution of this differential equation as x of t equals to a constant a e to the power of this number times t plus b e to the power of this number times t. So that is the generic solution. That's the general solution of the differential equation. And I have two constants there, so I have to fine-tune them so that this solution matches with the condition of the problem. So the problem tells you that initially means x of 0 is 1. So it means what? It means that when I replace t with 0, the answer is 1. If I replace t with 0 here and there, the exponentials simply become 1. So I will get a plus b equals to 1. This is one relation. And the second thing is that in the initially, we shoot the particle with the speed u, not velocity, speed u towards the origin. Because the initial location of my particle is on the right-hand side of the origin. When we shoot it towards the origin, it means that the velocity is negative of the speed. So this means that x dot at 0 is not u, but minus u. In order to apply this condition here, I need to find x dot first. So, and that's very simple. So I just calculate the derivative of that function with respect to time. So this minus 2 goes down, minus 2a, the function repeats itself. It's an exponential function. That's same for the other one. Okay, and now I say that x dot 0 is u, is minus u. So then this implies that I put 0 for t here and there. So this becomes 1, this becomes 1. So I will get minus 2a minus 8b equals to minus u. Okay, and now I divide everything by 2. I want to keep the minus sign here so that I can cancel that a there. So I divide by 2. It becomes minus a and minus 4b equals to minus u over 2. Okay, now I set up a system. The first equation is a plus b equals to 1. The second equation is minus a minus 4b is equal to minus u over 2. And then I add them, for example, a and a are gone, so this becomes minus 3b. Then it becomes minus u over 2 plus 1. And I divide everything by minus 3, so b becomes positive u over 6 minus 1 over 3. And of course, I can take the common denominator, u minus 2. So this is b. And what is a? So let me write b. b is u minus 2 over 6. This is the b. But for example, a is 1 minus b, so it becomes 1 minus u minus 2 over 6. If I take the common denominator, this becomes 8 minus u over 6. So a becomes, if I pull a minus sign out, it becomes u minus 8 over 6. Okay, so this is a and this is b. I plug them back into the original equation, then I will have my solution. Okay, so I put it back here, so x of t becomes equal to, instead of a, I put that expression, so it's 1 over 6 u minus 8 e to the power of minus 2t, and then plus b. But b is u minus 2 divided by 6 e to the power of minus 8t, and that is the answer that we are supposed to get here. Is that right? Oh, sorry. I forgot to put this minus sign there. There is also a minus sign. And that is the answer given in the problem. Of course, you should write it the other way around if you want to match it exactly with the form given in the problem. Okay, so that's good. Now, the other question is that, show that at the time t, when the particle is actually at the origin. That is the question. So if I want to calculate, I need to ask myself for which t, x of t becomes 0. Okay? So it means that I have to equate this to 0 and solve it. So if I put this equal to 0, yes, this expression is 0, I move this to the other side, so this means that 1 over 6 u minus 2 e to power minus 8t becomes equal to 1 over 6 u minus 8 e to power minus 2t. Okay, so this 1 over 6 and that 1 over 6 are gone. I multiply, I divide, so I will multiply everything by e to the power of 8t. So it becomes u minus 2. The right hand side becomes u minus 8 times e to the power of 6t. Yes, so I multiplied both sides by e to the power of positive 8t, that is cancelled, and that becomes 60. And if I divide by that, so it becomes u minus 2, u minus 8 equals to e to the power of 6t. If I want to find t, I have to take the logarithm and divide by 6, natural logarithm, of course. Then, but this is not wanted. You are supposed to prove this, that at this time fitting this equation, the particle reaches to the origin. And we want to show that actually the particle passes through the origin. We want to find the condition that the particle passes through the origin, because you know that this is a problem that we are supposed to, this is an equation we are supposed to solve for t, but we know that e to the power of 6t is always greater than 1, because time is greater than or equal to 0 in physics, so e to the power of 6t becomes greater than or equal to 1. Yes? So this equation has a solution if u minus 2 over u minus 8 is greater than 1. Otherwise, we do not have any solutions for this equation. And if I want to know the condition, I move this to the left. And then I take the common denominator here. So it becomes u minus 2 minus u plus 8 over u minus 8 should be greater than 0. Yes, I took just the common denominator here, and then this u and that u are cancelled, so it becomes 6 over u minus 8 greater than 0. But this happens if and only if u is greater than 8. Okay? Uh, so u should be greater than 8 so that it passes. Of course, it doesn't guarantee that it passes through the origin, because it guarantees that it can reach to the origin. Okay, but because of the word pass, I should show somehow that at this particular time, the speed of the particle is still not zero. The velocity is still negative when the particle reaches to the origin. Because if this has a solution, and then at that moment of time, the velocity also becomes zero, then it means the particle will stop at the origin. But I understand from the passing through the origin, or passes through, from the origin, it means that the velocity should still not be zero there. Okay, let us double check as well. So if I want to calculate the velocity as a function of time, I just differentiate this function with respect to time. So this minus 2 goes down, so it becomes positive 1/3, and then I have u minus 8 e to power 2t, and the other one becomes minus 8 over 6, which is 4 over 3 u minus 2 e to the power of, this is minus, sorry, e to the power of minus 8t. This is the velocity, okay? But I am not interested at velocity at any moment of time. I am interested at the velocity at this moment of time. Okay, so let us try to do the algebra, right? So what I will do, I want to do somehow some manipulation so that e to power 6t appears. So in order to do that, I prefer to factor e to power minus 8t out. That is good. And I also, so let me do this. I will go and factor, first of all, I can factor a third, and then I will factor e to the power of minus 8t out, yes? And then what is left? U minus 8 is left from here, e to the power of 6t is left, because if you multiply this back, it gives you e to power minus 2t, so my factorization is correct. Then it becomes minus 4, u minus 2, and this is pulled out, okay? This is the general form of the velocity as a function of time, but I am interested to know the velocity exactly at that time t so that it fits this equation. So it means that instead of e to power 6t, I can use that expression. So it becomes 1 over 3 e to power minus 8t, and then I have u minus 8 multiplied by that expression, u minus 2 over u minus 8, and then minus 4 times u minus 2. Agree? Now this u minus 8 and that u minus 8 are cancelled, so I get 1/3 e to the power of minus 8t. So here I have u minus 2 minus 4 times u minus 2. So it becomes minus 3 times u minus 2. Sorry, minus 3 times u minus 2. Yes? And now what happens? This minus 3 will cancel that. So it becomes negative e to power minus 8t times u minus 2. Okay? So this is the velocity of my particle at that moment, that instant of time, which is this number. But we know that this equation has a solution if it is supposed that the particle reaches to the origin. So this means that u should be greater than 8. So this means that this is positive, exponential function is positive, but because of this negative sign, at that moment of time, velocity is negative. So it means that it not only reaches to the origin, but when it is at origin, the velocity is negative, so it is still going towards the left. So this means that now combining these two, it means the particle actually passes through the origin. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.